Okay, so today we're going to continue our unit on curve sketching, and we're going to talk about maxima and minima, so maximum and minimum values, as well as something called the first derivative test. So we'll start with just a few definitions. I want you to just write them down, and then they'll make sense when we get to the example. Okay, so here are some definitions, and the idea here is just to distinguish between the word local and the word absolute. So it's a local max or min if the points sort of in the vicinity or nearby it are either all lower or all higher, okay? And then absolute is on the entire domain of the function or whatever we're looking at, the absolute highest point, and the absolute min would be the absolute lowest point, okay? And just one new term that we want to hear, local maximum and minimum values of a function are also called local extreme values. Or you will see in the textbook them called local extrema. So that would mean find the local max and mins. Okay, so let's look at this example. Okay, so in this example, let's start at this point right here. Okay, this particular curve right now has specific endpoints, so it doesn't have arrows continuing on to negative infinity and positive infinity. So this point up here is actually the highest point in this particular section, so we call this an absolute max. Now, it is a local max too. In other words, we would be able to solve for it as a local max because in this general vicinity right here, it is the highest point. Okay, so hopefully you could then see that this point down here is the absolute min. Okay, and hopefully it makes sense that this one over here is a local min. Again, not the lowest point on the graph, but in this general vicinity, it is the lowest point. And just a small little note, this one over here, that one's nothing. That's not an absolute max and not an absolute and not a local, sorry, it's not an absolute or local max or min. Okay? And just one other thing that we want to double check, I need you to read this box over here. When a question asks to determine the local max and local minimum, absolute max or absolute minimum, then really what it's asking for is the whole point. So we want to report the coordinates of the point, both the x and y value. But when a question asks to determine the local max min value or the absolute max or min value, then we're really just talking about the y value of that particular coordinate or point. Okay, so that's important to note when we look at questions. One other definition here from yesterday, we learned that a critical number of a function is a number, so an x value for which either the first derivative at that value equals 0 or the first derivative does not exist, i.e. comes from the denominator. So if x equals a is the critical number, the x values are the critical number, then I just want to make sure that you understand that this, of course, would be called a critical point, if you want CP for short. Okay, so let's look at our first type of question today. Okay, please pay attention really carefully to the words. We're going to determine the absolute maximum or minimum of that function, and note it's given a certain interval over here. We are given an interval, okay, from -3 to 2. So first thing, we're looking at absolute, not local, and note it says absolute maximum or minimum, so we are talking about the full point, right, not just the value. It doesn't say the value. Okay, so over here in the box, we find absolute maximum or minimums. We will find them at either a local maximum or a minimum or at the endpoints of the interval. So our first check is to find where could the local maximums and minimums occur. Well, this is at our critical numbers. So basically our first step is to find the critical numbers. So just like we did yesterday, let's go ahead and do that. See if you can pause the video and do most of that work by yourself. So the first derivative of the function is 6x squared plus 6x. I'm going to take that and I'm going to set it equal to 0 and solve for x. And then I can see that I get my critical numbers are x equals 0 and x equals -1. Okay, so now we find the absolute max and min by finding the highest and lowest y values using both the critical numbers and the endpoints. So basically now we want to look for the y values. So we want f at 0, that's one of our critical numbers. We want f at -1, that's the other one, and then also our endpoints. So we want f at -3, and we want f at 2. And then we're looking for the highest and the lowest. So why don't you pause the video, go ahead and find those y values. Okay, these are the y values you should have found. This y value at -27 is obviously the lowest, so this is our absolute minimum. Okay, the absolute minimum point is -3, -27. And this, of course, is our highest value, so this is our absolute max, which happens to be 2, 28. Okay, so that's our first type of question. That's our absolute max or min type question. Okay, and before we try our next type of question, I just want you to have this first derivative test. It's in your note if you printed it, and I want you to read it. So this one right here is our first scenario. This is A. So note here we have positive derivatives, right? Slopes of tangents would be positive. When they change from positive to negative, at that point where they change, somewhere right up here, this is a local max, okay? It could end up being an absolute max as well, but we don't really know that from the first derivative test. That's kind of the idea. Okay, and this second one right here, this is our B scenario. If our derivative changes from negative tangents or negative derivatives to positive derivatives, then this point right here is our local min. Okay, and then in this last scenario, these ones are both C. Note the derivatives never really change. Positive, 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 positive. Negative, 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 negative tangents and derivatives. Okay, and we're going to look at this in our next example. Okay, here we go. So the question says determine the local extrema. Remember that means local max mins for the function. First step, like always from here on in, is going to be take that derivative, set it equal to 0, solve for critical numbers. Okay, so I hope when you see this function you are thinking about the quotient rule. You should be using the quotient rule. Of course, it is possible to use the product rule here, but I do find a lot of people make mistakes. But I'd like you to pause the video. It's definitely going to take you a couple minutes, and I want you to find that derivative on your page and simplify it as far down as you can go to find those critical numbers. Go for it. Okay, so there we go. Check it out. If you stopped up here, it wouldn't be so bad. You don't really need to factor the numerator. You can just solve for x there. But of course, I'm going to use this as sort of my final line. Again, as long as you got the right critical numbers and you know what to substitute it into, that would be okay as well. All right, from the top, critical numbers, I hope you can see that you should have x equals plus or minus 3, so a -3 and a +3. That comes from the top. From the bottom, there are no values, right? This function has no vertical asymptotes. There are no values. That makes that denominator 0. In fact, it's always positive. So we can use that idea as we move forward. Okay, so let's set up our interval table. We just have a -3 and a +3. Pause the video and try to do that on your own. Okay, and again, how many lines you put right here doesn't really matter. This is the key line and this is the key line, and of course your top has to be set up correctly. As long as you have all of the components up here, that's important. If you factored a little differently and had a -2, it is important that you have the -2 right over here, because otherwise it will affect your answer. Okay, so watch out for that. All right, so let's fill in the interval table. Again, go ahead, pause the video, try to do that on your own, please. Okay, here's what I got. Note this row, always positive, right? Okay, overall, here we have negative. That means our function is decreasing from yesterday. Overall, here we have positive. That means our function is increasing. And overall here we have negative. That means our function is decreasing. So here our function is going from decreasing to increasing. This is a local min. Okay, where is the local min? It is when x is -3 and you have to find that y value over there. Here we're going from increasing to decreasing. So we have a local max. Okay, where the local max is at 3, comma, you have to find that y value there. Hopefully you guessed it. How do you find these y values? You take the x value and you put it into the original function, right? Okay, and so these are your local max and min points. Go ahead and do that. You should get -1/3 here for the y value and +1/3 here for the y value, okay? And you can write a concluding sentence, basically just summarizing all of this work right here, okay? So it's not too much more than what we were doing yesterday. You're going to need to take some time to practice. The practice questions are all listed in your lesson. There's a few in the textbook and then a couple little more challenging ones for you to try. Thank you.